In the last video we saw that certain continued fractions can get turned into square roots. In this video I'm going to show you how you can go in the other direction. Now the square root of 2 is about 1.4. Let's just say we know at least that crude estimate. So it's a little bigger than 1. So we could write a little bigger than 1 as 1 plus, and for the decimal part, I'm going to write it as 1 over x. Now you might say, well, why not 2 over x or whatever? Well, any decimal can be written as 1 over some other thing, like 0.9 is like 1 over something very close to 1, like 1 over 1.1, whereas 0.1 is 1 over 10. So we are allowed to put this 1 on top, and we're going to find the appropriate x that should go in the denominator. The way to do that is to subtract 1 from both sides to move this guy over. Square root of 2 minus 1 equals 1 over x. Then you take the reciprocal of both sides. I'm going to put the 1, when I take the reciprocal of 1 over x, I'm going to put it on the left here. And the other one I'm going to write is root 2 minus 1. Now 1 over square root of 2 minus 1, which is maybe around 2 point something, we're going to do a process that's called rationalizing the denominator. All rationalizing the denominator is when you have a denominator that has an irrational number in it, you multiply numerator and denominator by this, sometimes called the conjugate. We just take the opposite. If there's a minus here, we put a plus there. So the numerator becomes square root of 2 plus 1, but the denominator, you might remember the factoring pattern, that a squared minus b squared is a minus b, a plus b. Well, that factoring pattern is also a multiplying pattern. So this is a minus b, a plus b, and it's going to be a squared minus b squared. But a is the square root of 2, so square root of 2 squared is 2, minus 1 is 1. And it's very good when this is a 1 here, because that means that my process is finished. How do I assemble all the answers together? Well, remember this, square root of 2 is 1 plus 1 over x. So I write square root of 2 is 1 plus 1 over x, but the x is replaced with 1 plus square root of 2, or square root of 2 plus 1. I'll write it as 1 plus square root of 2, though. Which is 1 over oops, let me fix that up. Square root of 2 is 1 plus 1 over x. But the x is replaced with square root of 2 plus 1, which I'm going to write as 1 plus the square root of 2. But this square root of 2 is going to get replaced with this whole thing because they're both square root of 2. So 1 plus 1 over 1 plus, but instead of square root of 2, I'm going to write 1 plus 1 plus 1 over 1 plus square root of 2. But these two 1's can get together to become 1. And I'll just do this one more time. This square root of 2 can be replaced with 1 plus 1 over 1 plus square root of 2. So I have 1, this is the original 1, plus 1 over 2, plus 1 over 1 plus, and this square root of 2 is 1 plus 1 over 1 plus square root of 2, and those things become a 2. And that's why that will keep on happening forever, so we'll end up with 2 plus 1 over 2 plus going on. In other words, the square root of 2 can be written as 1, 2, 2, 2. Now this actually can be used as a way to find approximations for the square root of 2. If we just get rid of everything after the first plus sign, we would get 1 as our first approximation. If instead I do 1 plus 1 over 2, I get 3 halves as my second approximation. if instead I do 1 plus 1 over 2 plus 1 over 2, I get 1 plus 1 over 5 over 2, which is 1 plus 2/5, which is 7 over 5. If we go back here, we can actually see how we can continue the pattern pretty easily. So far we have 3 halves and 7 over 5. You might notice here that basically what happens is that you take your last approximation, if you add 1, take the reciprocal, and add 1 to that, it should get us to the next one. You see that happens here. If I take 2/3, 3/2, sorry, and I add 1, I get 5 over 2, and if I take the reciprocal of that, I get 2 over 5, and if I add 1 to that, I get 7 over 5. So we could try that for the next one, x3. I add 1, which becomes, add 1 to 7 over 5, I get 12 over 5. Take the reciprocal, it becomes 5 over 12. Add 1 to that, get 17 over 12. And I'll just go out one more that way. Again, I'm looking at this. Add 1, so 17 over 12 becomes 29 over 12. Take the reciprocal, becomes 12 over 29, and add 1 becomes 41 over 29. You might notice that the denominator ends up becoming the sum of the numerator and denominator of the last one, whereas the numerator is the old numerator plus 2 of the denominators, and that's something we saw with something called side diagonal numbers earlier in the semester. Here's an example for you to do. Try to do this process with the square root of 5. Try to do that now. Okay, now let me show you how that works. Square root of 5 is a little bigger than 2, so it's going to be 2 plus 1 over x. Then you subtract 2 from both sides. Take the reciprocal of both sides and rationalize the denominator. And we get radical 5 plus 2 here, but the denominator is radical 5 times radical 5, which is 5, minus 4, which is 1. It's always good when there's a 1 there. We'll see in the next example that won't happen. So x is replaced with radical 5 plus 2. So this is 2 over 1 plus, instead write it as 2 plus radical 5. But that radical 5 is replaced with 2 plus 1 over x. And those 2's become a 4. So this becomes square root of 5 becomes written in this form, 2, 4, 4, 4. It can get a little bit harder. For instance, the square root of 3 is actually more difficult, even though you look at it and say, well, it just starts the same way. Square root of 3 is between 1 and 2. So it's 1 and a little bit, or 1 plus 1 over x. But look at what happens when you go through the process. Radical 3 minus 1 equals 1 over x. X equals 1 over radical 3 minus 1. Rationalize the denominator. You get radical 3 plus 1 in the numerator, but the denominator does not become 1. It becomes radical 3 times radical 3 is 3. 3 minus 1 is 2. Well, this is problematic. Because this x has to be sort of a simpler thing. So what we have to do now, and this is real annoying, square root of 3 is about 1.7. 1.7 plus 1 is about 2.7. 2.7 divided by 2 is a little bigger than 1. So we have to say that this thing is 1 point something, or 1 plus 1 over, and I'm going to call it y now. So I can at least say 1 plus 1 over x became 1 plus 1 over y. But what is that y? Well, we take this equation, radical 3 plus 1 over 2 is equal to 1 plus 1 over y. And we subtract 1 from both sides. 1 is kind of like 2 over 2, so it becomes radical 3 minus 1 over 2 equals 1 over y. I got that by taking away 1 from both sides and using common denominators. Plus 1 minus 2 is negative 1. Now you take the reciprocal of both sides. I get 2 over radical 3 minus 1. Then I rationalize the denominator. And the denominator here becomes radical 3 times radical 3 is 3, and minus 1 times 1 is 1, so it becomes 2. So that's annoying because we really wish that was a 1, because that's how the process gets to stop. But look at the numerator. If I leave the numerator as 2 times radical 3 plus 1, the 2's cancel out. And y becomes radical 3 plus 1, which, if you don't mind, I'm writing as 1 plus radical 3. Okay, now the process gets to finish, because here I was 1 plus 1 over 1 plus 1 over y. But now, instead of writing y, I'm going to replace the y with 1 plus radical 3. Now I can replace this radical 3 with the entire expression, so it becomes 1 plus 1 over 1 plus 1 over 1 plus y. And these two 1's get put together to become a 2, but this one gets to stay a 1. And if I do it again with this y, 1 plus 1 over, these two are going to come together to become a 2. So it happens that the square root of 3 actually turns into 1, 1, 2, 1, 2. It alternates. As a challenge, you could try to do this with the square root of 11. It becomes 3 plus 1 over x, root 11 minus 3 equals 1 over x equals 1 over root 11 minus 3. Rationalize the denominator. Get radical 11 plus 3. This becomes 11 minus 9 is 2. Now, square root of 11, we need to know that's a little bigger than 3. And a little bigger than 3 plus 3 is a little bigger than 6. And a little bigger than 6 divided by 2 is going to be a little bigger than 3. So I'll call it 3 plus 1 over y. Now when we take this expression, so this turns into equals 3 plus 1 over, instead of x, I'll write 3 plus 1 over y. But to calculate that y, I subtract 3 from both sides. 3 is the same thing as 6 over 2, so this becomes root 11 minus 3 over 2 equals 1 over y. So flip both sides, 2 over radical 11 minus 3. Rationalize the denominator. That should be plus 3. And we get 2 radical 11 plus 3 over 2. The 2's cancel out. So this y turns into 3 plus radical 11. But that radical 11 starts with 3 plus, and that's where That's where these two 3's come together to make a 6, and radical 11 is going to alternate 3, 3, 6, going back and forth. And if you're looking for an extreme extra challenge, try to do the square root of 14. Okay, I don't have the work handy, but it should become 3, 1, 2, 1, 6.